And circle of death, and come on. Come on, internet, you can do it. Recording, all right. So Extrema, those are just local maxima and minima. So if, for example, we have a function that looks like that. These would be our extrema. So these would be local mins, these would be local maxes. This one does not have a global max or a min because it goes off to infinity and negative infinity. So it does not have a global overall max or min, it only has local max and mins. But if we had something like this one has a global max. Or an overall maximum. And then this would be a local min, and this would be a local max. So it's only a global if it's overall for the entire function, the maximum value of the function, and it's local otherwise. So for Extrema, all we really have to do is plug the function into a graphing calculator and click on the points. So if you have a Desmos, that's really easy to do. If you do not have a Desmos, or if you want to see how to do it on a TI calculator, we're going to do that really quick. I'll show how to do it on the TI, and then I'll show it how to do it on the Desmos. So if you are on your TI calculator and you just type in a function, we'll go x to the fourth plus 2. Actually, we'll make it even simpler. We'll go x squared. All right, we'll just do a quadratic to start with, since I know that that'll probably be within my window. So we hit graph, and it graphs it for us. And then you would hit second calc, where there's all these things like zeros and minimum and maximum and whatnot. On the graph, notice that this one looked like it had a minimum, not a maximum. So we're looking for the minimum. So you'd hit enter, and then you'd go over to where somewhere to the left of your minimum, and you'd hit enter. And then you'd go somewhere to the right of your minimum, and you'd hit enter. And then you'd hit enter again, and it will tell you what your minimum value is and where it's located, the X and the Y coordinates there. And I know that's kind of fuzzy looking, but that is how you would do it. If you have other questions about how to do it, or you would like to do one again, feel free to ask later. On Desmos, we could do the same thing. X squared. We had plus 2x plus 5. There it is. We can click on it. And that would give us our minimum value. All right. So basically in Desmos, you're just clicking on the TI calculator. It's slightly more work, but that's the calculator that you're going to end up using in AP Calculus and on the AP test and things like that. So that would be a good thing to get used to using if you plan to take AP Calculus or AP Statistics. They'll also have you on a TI calculator. Also, one other thing, you might notice that the minimum here that it listed is negative 0.9 repeating. That's equal to -1. So anything with a 0.9 repeating is equal to that rounded up whole number. So yeah, negative 0.9 repeating is the same thing as -1, as you saw exactly on Desmos, it gave you -1 and 4 for your coordinates. Anyway, that's Extrema. Then we've got average rate of change. So that's coming up next. Average rate of change. So new topic. All right. So I'm going to kind of write out the definition here and move the water bottle out of the way. So it's stated as for an interval of the domain So for example, if we had the interval 3, 5 or something like that. So for an interval of the domain, the x values, the average rate of change is the slope of the secant line between those points on the graph. So in our example here, if we were taking the domain, this interval of the domain to be 3 to 5, it would be the slope between the point 3, f of 3, and 5, f of 5. So as a picture, if we had something like this, where say this was 3 and this was 5, here's the secant line, and it would be the slope of this line is your average rate of change. So the slope of that line is your average rate of change. So really all we're doing is the slope formula between the 2 points. Okay, so we're going to do an example of this. All right, so here's our function. F of x equals x squared plus 3x minus 4. And we want the average rate of change on the interval -1 to 2. Okay. So the things that we need to know in order to do this, we need to know -1 f of -1, and we need to know 2 f of 2. So that means we need to figure out what f of -1 is. So to figure that out, we plug in -1 to the function. -1 squared plus 3 times -1 minus 4. And let's see, -1 squared is 1 minus 3 minus 4 gives us -6. So our coordinate is the point -1, -6. Then our second coordinate, we need to find f of 2. So we plug in 2 and we get 2 squared plus 3 times 2 minus 4, which gives us, let's see, 4 plus 6 minus 4 is 6. So our second coordinate is 2, 6. So we need to find the slope between -1, -6, and 2, 6. All right. So slope is change in y over change in x, or y2 minus y1 over x2 minus x1, however you prefer to think of it. So in this case, if we go x1, y1, x2, y2, 6 minus -6, and then on the bottom, 2 minus -1. So on the top, that gives us 12. On the bottom, that gives us 3. 12 divided by 3 is 4. So our average rate of change is 4. So that would be our average rate of change. So we're just finding the slope. Any questions about that one? Any numbers we're not sure where they came from? Steps we're not sure why they happened. Okay. In that case, let's do another one. And then you guys will do one. If you would like to move ahead and do this one on your own too, by all means, go for it. For this one, we are going to have our function f of x equals x to the 4th plus 2x to the 3rd. That's a 3, I promise. Minus x minus 1 on the interval -3 to -2. Okay. So first thing we need to do is plug in -3 to get f of -3. So -3 to the 4th plus 2 times -3 to the 3rd minus -3 minus 1. Okay. If you're great at finding things to the 4th, awesome. If you're not, plug it into a calculator. -3 to the 4th is positive 81. Don't forget that when you have even powers, it's always positive. So when you plug it into a calculator, if that's what you're doing, make sure you put parentheses around the number. So if you did it like this, it's going to give you a negative number. If you do it like this, it's going to give you a positive number. And that should be positive. So when in doubt, put parentheses. Anyway, 81. -3 to the 3rd is -27. Times 2 gives us -54. Minus -3, so that'd be like +3, minus 1. So 81 minus 54 plus 3 minus 1 is 29. So one of the coordinates we're working with here is the point -3, 29. Then we have to do f of -2, which is -2 to the 4th plus 2 times -2 to the 3rd minus -2 minus 1. All right. So -2 to the 4th is positive 16. -2 to the 3rd is -8. -8 times 2 is -16. Minus -2, so that's +2, minus 1. So these cancel. 2 minus 1 is 1. So the other coordinate that we are working with is the point -2, 1. So then we just have to find the slope between those 2 points. So we subtract the y values on top. So I'm going to go 29 minus 1. Subtract the x values on the bottom. -3 minus -2. That gives us 28 over -1. which is negative 28. So that will be our average rate of change here. Okay. Any questions on this one? Any numbers we don't know where they came from? Steps we're not sure why they happened. Okay. If you do, feel free to unmute and say so. Otherwise, your turn. All right, so that's going to be, your function is f of x equals, we'll go x to the fourth plus 2x to the third minus x minus 1. Oh, it's the same function. That's funny. Then we'll do on the interval instead this time -1 to 0. I'm just grabbing problems from my worksheet, so that's funny. I didn't notice that they were going to be the same. Oh well. There's your function. Go ahead and find your average rate of change here. Once you think you've got it, type done in the chat. Or if you have a question at any point, feel free to ask away. All right, looks like most of us are finishing up here. If you were working with the points -1, -1, and 0, -1, you were on the right track. And then how many of you got the average rate of change was 0? You got 0, type yes in the chat. All right. Yep, 0. So we had -1 minus -1 over 0, or sorry, -1 minus 0, or either way around. 0. Okay. That is pretty much everything that we've got for today that is new. So if you found this easy, then yay, it's an easy day for you. If you found this difficult, you're about to get some practice. Today's practice is in IXL, but it's only one section. And I will post it in just a moment, but while I'm posting it, some of you have said that IXL is running slowly, and that could be your internet, but it could also be your Chromebook. If you have not cleared the cache on your Chromebook in a while, that could be making things like Google Meets and IXL or any other application that you're using run kind of slow. So here are the steps on how to clear the cache on your Chromebook. You open your Chrome browser, you click the 3 dots. You go down to More Tools, and then you go to Clear Browsing Data. So More Tools, Clear Browsing Data, and then you click Clear Data because it will clear your browsing history and all that kind of fun stuff. Any images and files, it frees up space and stuff like that. So take a moment and clear the cache on your Chromebook. If you need those steps, I'll post those in the chat real quick, that link. So there you go. And then I'll post the assignment while you guys work on clearing your cache. Okay. All right, so the assignment for today is IXL Pre-Calculus A10. It's about average rate of change. So make sure you log in with Clever, click on the link for IXL, and there you go. And then for the 2 of you that wanted the 6.1 to 6.3 retake, your retake is also posted. And then the rest of you who, if anyone did not turn in your quiz or did not start or finish your quiz, make sure that you do those things before you start working on this. So the quiz is the important part. If you have anything to do on your quiz, do that first. Okay, so that is everything. Towards the end of the period, I will post the exit ticket. Otherwise, unless you have questions about anything, you are free to head out. I'll be here the rest of the period. If you do have questions, pop back in.